Welcome to the Grid Mod Pod, brought to you by AEIC. In this podcast, you'll hear from the utility industry's top operations leaders on how their companies are working to modernize and improve our ever-evolving power grid. Thanks for joining us.
Hello, and welcome to the Grid Mod Podcast. I'm your host, Dr. Elizabeth Cook, and in this podcast, we're going to explore the latest trends, technologies, and insights of the ever-evolving energy sector. And today, we have the pleasure of hosting George Dobbins, the Interconnection and Policy Manager at Alabama Power. With George's in-depth knowledge and our focus on grid infrastructure, policy considerations, decentralized energy, and electrification of transportation, very broad, but so is the grid modernization topic, right, George? We're going to really set for a thought-provoking discussion. So let's dive into where the future of the power system is going. And to kick us off, George, take the opportunity to introduce yourself.
Thank you, Dr. Cook, for having me today. I'm definitely excited to be here to talk more about grid modernization topics. I'm the Interconnection Manager at Alabama Power Company. My team manages all of the transmission level interconnections to our system. So that's our wholesale interconnections, retail interconnections, as well as any distributed generation or distributed generation interconnections as well. So I've got a team that's focused on that and focused on all policies around that as well. So Alabama Power Company is a vertically integrated utility. We are regulated by the Alabama Public Service Commission, and our parent company is Southern Company. So Southern Company has electric utilities in both Georgia, Alabama, and Mississippi. Alabama Power specifically serves 1.5 million customers, and we have a fairly diverse resource mix consisted of both nuclear, hydro, renewables, coal, and natural gas. So thank you for having me again.
Yeah, so it is a broadband knowledge that you do have. And what I picked up on was, from when we say in the electric utility space, interconnections, it is ultimately the grid has to do particular studies to determine that the generation or whatever device that a customer wants to connect to the system at this point follows the right protocols, fills out the right applications, and does everything adequately and correctly. And just for those listeners maybe privy to, unlocking the queue or knowing that we are in a transformational change at the transmission level, let alone the distribution level, because of all of these new energy sources that want to connect. And you're right there at the middle of it in Alabama Power. So this is going to be a great conversation.
Yes. I'm looking forward to it.
Yeah, so George, to begin, could you shed light on really the current state of our grids, infrastructure, and some essential upgrades that are needed as we evolve into this space of new interconnections and all of those generation devices that want to connect?
Yeah, definitely, Dr. Cook. So I think, probably most of our viewers know that from a grid standpoint, you've got more distributed energy resources connecting to our system. So whether that's renewable generation, particularly energy storage and what have you, that's starting to impact just really the infrastructure that we have in place. So if you think about it, if we're retiring a plant that might be in the north part of our state, and a lot of the renewables that we're seeing are maybe in the southern part of the state, we had infrastructure built to distribute energy from that plant out. And now, I may have a generating asset that's in the southern part of the state that's now generating and could potentially be impacting the flow on the system. And so we're really having to relook at our systems, relook at the infrastructure that we have in place to best meet get the generation to where our load centers are and where that need is. And so it's really a transformational time for us as a company. It's going to require some significant investments on our part as a utility to really push forward and ensure that we're maintaining the same level of service and same level of reliability that our customers have enjoyed over the past century plus for us as Alabama Power. So that's really where we're at on infrastructure. So I would say it's just an exciting time from a standpoint of what we're in the process of studying and the process of doing, but we've just got to make sure we've got the right assets in place to get the generation to the load.
For some reason, the whole time you're talking, I was thinking of this analogy, and I just have to share it. So you ever walk out into the early morning and you see that spider web that beautifully designed with all its little points? Like really, if we think about what we're trying to do is that design with all the intersections is like where your generation was to really ground and source where the flow is. And what is happening is on a daily basis, we have generators or people that want to develop in that space and putting it all over that spider web. So the job of an interconnection manager is really to holistically see that so you can adequately redistribute where the electron flows are. I guess from your experience, have you seen any upgrades that, have shown, or any tools in your toolboxes as the utility space that gives us that overall efficiency and capability to kind of maneuver and enhance?
And so, we're always looking at different technologies. I think that's a great analogy, by the way, as far as our grid and the tasks that we have ahead of us is really to strengthen some of those, we'll just say, ties to where that generator is locating. So that's just things that we look at. We run studies for each generator that wants to interconnect. And with those studies, it'll basically dictate what upgrades are required to allow them to interconnect and output into our system. From a standpoint of technologies that are out there, there's a lot of technologies that are still, we'll just say, in the developmental stages. Some have been out there for a while that, let's just say, as an example, like one that can impact we'll say, impedance. I'm trying to make more layman's terms to say this, but the resistance of the line to kind of help direct the flows as you need to. So you have technologies out there, but for us as a utility, we continue to look at some of the more traditional, obviously the line upgrades being maybe the more robust solutions. But then battery storage is again another technology that gives us a little bit more flexibility on our system, to where we may have a facility that's generating in the general area. We don't necessarily need their full output. We can store that energy and then distribute it at a later time when it's needed. And so those are some of the things that we're starting to look at. But obviously, all the tools that we have in the toolbox, we're really considering and just trying to do what's best for our ratepayers and for the system.
Right. And so another just analogy is with the battery energy storage, and why I think, it is a hot topic in our space, is if that capability to store energy that is produced at one time and used at a later time was available to the Thomas Edisons and George Westinghouses of the world 100 plus years ago, how we constructed and facilitate the power grid would be completely different. Because, I think a fun fact that not many layman's people understand is that we as a society that have very robust, reliable grids, the exact amount of electrons that are being pulled from the grid by our customers that are using at the same time as what is being produced. So that in itself is very complex. So that's what you're dealing with when you just suddenly disrupt it. We have to realize that we have to have that perfect meld until we can really deploy technologies that can store at massive levels. And so I think that's the projection we're on, is trying to prove out those technologies. So they are here, but it takes a lot, even for each individual utility, to embrace, understand, right, plan, design, standardize, and then run out those projects. So it can't happen overnight.
No, you're exactly right. It definitely cannot happen overnight. And to your point, the grid would look a lot different if the technologies were available back then. And just for us, we consider, again, battery storage is one of those items that we're looking at heavily as a utility. We've also looked at some of the more traditional storage options, pump storage being one of them as of late. You may have seen articles on just basically our assessment, and they're just with those type storage options, there are a lot of challenges just from a timing perspective, just planning it out. And then just you have a lot of hurdles to overcome, where with the battery, it's pretty much a tractor trailer size, let's say, part, and you scale it up as you need to. So a lot more flexibility, a lot easier to deploy. And so we're definitely looking into that and looking for opportunities to deploy that on our system.
And this is maybe a rhetorical question, but I just have to add it in there. One thing that comes up on the Grid Mod Pod quite a bit is the power of data and having access to information that we have not yet had. So if we think about the power flow equations and all of the computational power that we currently have to run those studies that we all are running, I think there's a space where that's going to evolve very quickly on what that software looks like and what you're optimizing against. So it's a very exciting time. And I think we're pushing the limits every day. It just, I don't think everyone sees that inertia. No pun intended.
Yeah. That's a good one.
So being that your other half of your job, not only connecting the technology of the interconnection, let's say, you have your policy side. So what impact do you think, the evolution of that discussion has on the overall grid infrastructure? So have you seen any?
Just want to make sure I understand the question. So around the policy impacts on just overall grid, is that the question?
Right. Like, how have you seen in your space, the changes or the dialogue or just the discussion that, has given opportunity to really evolve the grid infrastructure in general?
Well, I think it's been huge. And so I go back to my days at Georgia Power, and you look at some of the investment tax credits that were out there for really growing the renewable generation resource base or mix. And we saw basically some of the fastest growth in our area that we had seen for some time because of that. So the more you can incentivize some of this growth and development, I mean, obviously the developers and different entities will take advantage of that. And so policy plays a huge role in just advancement of, from a generation standpoint, like I said, the renewable growth that we've seen over the past 10, 15 years. But then we start fast forward and it's like, okay, we've seen that growth and we started to see some of the impacts to the grid. And you've got to make some of those same investments in our grid to continue a healthy level of growth to where it does not impact reliability and it does not impact the overall service we provide to our customers. So again, just policy will play a huge part of that. The more we can incentivize those type of investments, the more we'll continue to see the growth that we want to see in renewable generation and more of the distributed generation as well.
And I think, just to level set, when this topic, grid modernization, is very broad and, however, very dynamic. And I think, one part of the conversation is, we have infrastructure that has been around for, the idea of and the capability 140 years. Hopefully we won't have equipment that old. But the majority of our equipment is aging in the respect of it works, the ratings are there, the standards, like how it's done, we understand it, it's been vetted, it's been proved out, but it needs upgraded.
Yeah.
While that is occurring, we're having this transformational change of affordable, scalable, dynamic devices that want to play on that existing grid.
Yep.
And so when we think about policy and regulatory, like here, across the states, 50 states that if you look at all of them as a whole package, they have approached how to enable this new technology in very different ways. And then you also have the ownership model, like vertically integrated that you sit in versus like in the state of PA, you're not allowed to own generation. So I think from like the outsiders looking in, it's very important that everyone kind of grounds themselves in, what was the provocative or maybe change in language that like launched the certain technologies. However, one thing that I think, in the space, probably you and I can agree on, the complexity is there, but I think if we peel back the onion, to simplify it, if we can understand the current assets, right, and how they perform today, to get to that information, to be able to move us forward, is really the same technology and ideology that will prepare us for this new reality. And so, like, the one thing that's happening right now is you have, and we were talking about at the beginning, you have these bulk generation plants that were very centralized. So you installed your 2,000, 4,000 megawatt bulk transmission generation sources, and then you stemmed off very large transmission systems. So we called that centralized. And then what you've been seeing, as you've been talking about, is the introduction of your residential or larger C&I connecting at the edge. So now you're in this world of decentralized energy generation. So from your perspective and watching that evolution in your experience, what has been some of the benefits you've seen, but also, of course, we don't want to call them challenges, let's call them opportunities in regarding integrating those smaller devices into the bulk. So we're starting to decentralize. What has been your
So I'd say, benefits is to me I think it's back to the maybe old adage, the closer the generation is to the load, kind of, so as a general rule, you would expect maybe a greater level of resiliency. So that's to me definitely a benefit for customers is, to where if I had we'll say 50-mile line that was servicing them from a generation, there's opportunities for things to happen versus if it's on site or sited near their facility. Because, again, for us, we really are looking for more utility-owned type applications. But if it's closer to the site, closer to the load, the more resilient the service that we can provide to the customer. And so that's definitely a benefit for our customers. That's something, again, we want to capitalize on. I'd say as far as the drawbacks, it gets back to some of what you say, the visibility of if it's a customer-owned system, the visibility that we as a utility or system operator have into their system is definitely an area of concern, and it's something that we have to address. And so I know, you have your different, we'll say, DERM systems or distributed energy resource management systems that are out there now. They've come a long way. That's another, let's say, developing field where a lot of, again, I look back 10 years ago, there were a lot of smaller, maybe startup type companies in that space. And putting out applications and products to where now you have a lot of larger companies that have actually purchased some of those smaller companies. And so that just to me speaks to the magnitude of the change that we're seeing and the investment opportunity for those companies as well. So visibility is one. I think communication is another challenge that we've seen. So, if you have a system that's, behind the customer's meter and for some reason, we need to communicate to it to either increase or decrease generation. What level of technology will we have in place to be able to do that and carry that out? And again, those are not systems or equipment that we currently have on our system. So we've got to deploy that. We've got to install that and invest in those type assets.
Just listening to what you said. So I heard technology a lot. And I think, have we made it overly complex, especially the space that we're sitting in? Everyone sees opportunity. Those that currently own and operate and manage and are required for safe, reliable, affordable power. There's also the innovation and the capability of all of these new devices. And teeing back to the earlier comment is the technology that we're talking about is we can still facilitate this world that we're talking about with the existing assets, but having the correct communication, so the ability to talk to all of this new equipment and new devices, right? And then having that understanding and knowledge from a technology, and this is really IT, right? Infrastructure that brings back the data, that you can analyze it and then distribute the information in ways that makes it actionable to those that have access to it, is really the transformation we're talking about. So we went from a power grid that was predominantly being operated with the physical assets, and they did their job. Very limited communication because everything was very predictable. We almost set up a system to be predictable based on ramp up times and ramp down and how we as beings use energy. And where we're shifting to is, and as you said, and we don't all have it yet, and that's really the key, is enabling those that own the assets to facilitate and manage all of this change to have that full situational awareness. So that requires censoring, the measuring, the communication network, and then the technology, IT, software, hardware to take that data and drive it.
Yeah, absolutely.
And then that's going to lead into my last, general idea is something else that's happening in your space. Not only is this new generation wants to connect because there's old generation retiring and new technology itself or how it's generated. There's something happening in our world. It's called electrification of transportation. Yes. And so what that means to the utility owner is load growth, which predominantly from the 1980s and 90s, we were like, wait, we're not going to be able to continue to live on this trajectory of energy because our grid's not big enough. So we've created processes, and the people that are employed only know the world of no load growth. So we're suddenly, and that's what it means to us, load growth. So when we talk about load forecasts, they've been flat or declining, some areas popping, but we just resorted back to the wired solutions that we've been using for 100 years. But now the electrification of transformation, with the rise of those vehicles, what implications does this have from your perspective on the power grid that you're in charge of?
Yeah, so for our grid, and it's, I mean, all the things you said, I just want to kind of pause and like, there is so much going on right now in our industry. Again, just we talk generation, decentralization, we talk infrastructure requirements, upgrades needed in order to facilitate that, and then you're talking the load growth. And electrification would give us load growth that we've not seen, to your point, for some time. We've had healthy growth in the Southeast generally, but there is a demand level, and I liken it to maybe some of the on-demand water heaters. There's a level of car pulls into a, let's say, charging station, it plugs in. That's like an instantaneous demand on our system that we've got to be able to serve, and it's not something that we have planned for. I mean, it's we had mostly gas fuel vehicles over the past again, centuries. And so now we've got the electrification of fleets. We got electrification of vehicles. Even here in the state of Alabama, I was just having this conversation the other day with some colleagues. 10 years ago, it would be like an oddity almost for me to see an EV on the road. And I look now, it's like, I can't get out and drive to work without seeing, an EV. And it just, to me, amazes me the level of adoption that we've seen within our state. And so on the charging side, it's, we've got to be equipped because we don't always get, let's say, the notification. We don't always get notified by the customer that they're installing it. But we do have, it's back to your point of data. We have ways to go out and, say, pull a report and check and see an increase in demand, and we're able to address it. But we've got to have the right transformer capacity. We've got to have, let's say, the lines to support it. The amount of load that you can see. So individual home load, we'd have to see significant growth in an area over a period of time for it to really, cause an issue. When you start looking at some of those charging stations where you got, 5, 10, 15, 20 chargers in an area, that's just a huge demand on our system that, again, will require further upgrades in order to facilitate. And, from an industry standpoint, again, we're looking for options and looking for ways to service the load as most economically and efficiently as possible. So you hear about, terms like battery buffering. Can we use batteries to help kind of shave that demand down to where it's not as great of a demand on the actual electrical system? And so those are things that we as a utility are starting to look at, starting to consider and figure out how to deploy on our system to meet that demand.
As you said, there is a lot going on in our industry, and I find, the electric utility space is at the epicenter of that. We've created these machines that we also now depend on as a lifeline to our society. And so, one, it's such a great place to sit in because I think any work that we do or anything we can contribute, we're actually, true value is being given to really serve our communities. I think, one of our missions and it's, we get buried in the details, but if we pull back up, there has to be really a win-win-win situation. The space that we sit in, we're kind of at the epicenter, like I stated, and then there's, the vendors, there's the policy, there's the business model, and then all of those that want to just be a part of the solution. If we connect the dots, and I guess I said it earlier, like if we understood like how the grid was really performing all the way to the edge, and we're allowed and to tap into that, like, the solutions are there. But it will take time. And I think it's important that everyone's coming to the table with that awareness and fighting for or realizing that there's enough for all of us to play a part of it, right? Instead of siloed discussion that, we need the bulk generation. We need all of the different energy sources. We need to embrace and accept our customers' desires and approaches to really make us be able to move forward. Yeah. And I guess I have to share a little anecdote. In my younger years, if we saw a Volkswagen Bug, it like excited us. I don't know if it excited you down the south.
Oh yes, absolutely.
It was like, there's a bug. But now I don't even talk about electric vehicles really that much with my children. And my 5-year-old, anytime he sees a Tesla, he like lights up. And it's like odd because like, where is he getting that messaging? But yes, they're like now everywhere. And that is load growth, not only even if it's a little bit. That's another thing I think we as a group of peers have to understand is everyone has their set of feeders and every feeder is different, right? Everyone has their transmission grid, but every transmission grid's different. So there is no peanut butter spread answer, but there is like the grounding philosophy. So if there's one little change. It takes a set of engineers to, within that space, to like define, understand, believe in it, and then take action. So it's really important that we're communicating, educating, and really driving that change through, all that we do.
Yeah, and one thing you said, Dr. Cook, is really the collaborative approach to what we're facing. I think that is like the key of it all, and all of the different entities that are engaged in this space. I'm just taking a collaborative approach to it and just understanding and doing that. We will find the best solution. I do have faith in that. So
I'm just going to go down this rabbit hole with you. Like, Stephen Covey, the win-win, like there's a win-win-win scenario. I truly believe in, right? So like we're sitting in the technology, the policy, and then the business model. It's a triangle. So if we have collaboration over the competition that we face, we are a monopoly within our own space, but all of the capabilities and the tools and the technology that are available are competing with each other. But there's enough for all of them to be part of the solutions. I agree. And so like differentiating yourself and being innovative is welcome, right? And it shouldn't be hindered. And then, a part of all of this discussion, throw in the wrench, safe, reliable, affordable power is the requirement of a utility from a technical, delivery perspective, is now sustainable and resilient. So like just having those groups, those three models, understand those pulls and those like tugs. I mean, there is a solution, but we have to come to the table with that collaborative nature.
Exactly.
We can't forget the customer too. No, sorry, all you customers. It has to be customers.
That's right. Customers in the center, So they are
at the center. That's like, I remember one moment I gave this presentation on grid modernization, like what it all means. And then someone like, after all of it, I thought it was the best one I ever did. What about the customer? And I was like, what do you mean, what about the customer? It's all for the customer. But unless you say it, people don't hear it. So that was a big takeaway. So, well, we could talk forever because we were in the same space. Just, thinking about the journey you've been through and kind of challenges you've faced. Something I like to say is, obstacles do not block the path, they are the path. But for all those listeners, and especially some of the emerging interconnection managers that really didn't see a whole lot, and then they suddenly got hit with something different, what's a lesson learned or just a piece of advice that you'd like to give those fellow peers?
That's a good question, Dr. Cook. For me, I think it's to your point of what you said, just continue pressing through. There is enough, let's say, ingenuity within our industry, within our space to tackle any obstacle. Again, I think back to kind of how we've transitioned over the years, and it was almost to a point of new stuff we were almost anti. We can't do that; it'll impact the reliability of the system and affect the service to our customers. And there's enough ingenuity within our space to find a way to make new technologies work. And not only work, but be of a benefit and an added resource for our customers. And so that's really what we're starting to see, because we're transitioning, even on the, let's say, economic development front. You're seeing, customers with all their renewable energy goals to be competitive, to compete for that load. We have to have a program for them, to get them here. So I just say, rest in our ingenuity to figure out the solution to some of the obstacles we face. And don't let that deter us from adopting new technologies. Will be my piece of advice.
Great. I love it. So as we wrap up today's engaging session with George Dobbins, we've gained, I think, valuable insights, really, of the critical aspects of grid modernization. It's vast, it's large, but if we peel back the onion, there's some simple points that we can really grab and take hold of and go forward with. So I thank you, George, for your expert insights, and for our listeners to continue to join us on this journey. So stay tuned for more Grid Mod podcasts.
All right. Thank you so much. And I appreciate your energy and the time today. It was awesome.
That's a wrap for this week's episode of the Grid Mod Pod. Thanks for tuning in. We hope today's conversation got you thinking about new and creative ways to improve our power grid. Be sure to subscribe to our YouTube channel to be the first to hear new episodes. This podcast is brought to you by AEIC, the place where operations leaders come together to share knowledge and provide guidance to the electric utility industry. We'll be back with a new episode soon. Until then, keep powering on.